All right, so we're back for the third and final segment of today's program on infrastructure. Our next speaker is Todd Greene, CEO of PubNub. Todd is a serial entrepreneur who has founded and successfully sold companies across the software spectrum. As CEO of PubNub, he helps shape the vision of revolutionizing the way people interact online. Todd most recently was CEO of Loyalize, an audience participation company. And Todd previously was also founder and CTO of Cascade Works. Todd, over to you.
All right. Thank you very much. Can everyone hear me okay? I think so. All right. Well, thanks a lot for the time. I'm going to break a bunch of rules today. First of all, I am going to give a presentation without lots of rehearsal. So that's one thing you're never supposed to do. Second is, for the first time in my life, and all the presentations I've ever given, I'm going to actually use notes off my phone, which is really, really cheesy. But, you know, I've got a lot of good ideas I want to share. And then third, you're always supposed to get a great night's sleep before presentation. I just learned that from Arianna Huffington last night. She published some book, I guess, about this. I've had 6 red eyes in a row. So I might just completely collapse on stage, in which case, just take me out. But anyway, how many people here have heard of PubNub? How many people here know about us? Great. That's a great percentage. So we've been through 3 rounds of financing, Sapphire being our most recent, so great relationship with them. And we've been really, really kind of impressed with the group. Remind me afterwards to tell you guys a story of how they all came in and then left our pitch to go to a bachelor party, which is a whole other story. The title of this is Challenges of Building and Scaling Always-On Apps. I want to kind of talk about that, but in the context really of 3 trends coming together that we see: data streams, microservices, and changes in the way we think about networks. And so it's maybe as part of telling that story, walk through a little bit of the history of why we started PubNub and how, and go from there. So first of all, for those of you who don't know what PubNub is, we're a company that is provided, we call it data stream network. And what we really do is make it really easy for people to do 2-way or multi-way communication between any kind of device, low latency, but real time, reliable, and secure. So we have lots of different companies that use PubNub in a lot of ways, which I'll talk about. But the key things here for us are basically data stream network being a key word here, and the world, meaning something global. So there's lots of, any kinds of devices anywhere can communicate in real time. So why did we start PubNub, and what's the difference here? So first of all, for the last 15, 20 years, everything's been designed around API endpoints, right? So all the way we've designed applications, whatever kind of application, has been request response. Interestingly, kind of everything comes full circle, because if you came from the SOA world or the EAI world or the messaging bus world from TIBCO, it used to be about messaging buses and messaging endpoints. And then we went to this REST-based where it was much more about the API economy, right? And now all of a sudden, there's this trend toward data streams where all of a sudden, devices are always on, always listening. And the kinds of applications people are trying to build that are more real-time don't really work in a REST-based model here. So a few companies that use PubNub today, really across a lot of different kinds of use cases. Everything from, on the social entertainment side, Pocket Gems, Periscope, Life360, Autodesk for business collaboration, financial services, audience participation, smart home. So Logitech uses us to turn lights on and off. Any kind of multi-way chat or 2-way chat applications. Making phones ring, voice over IP phones. You need to have a connection, an always-on connection to a device, and make that device ring or activate. Connected vehicles, Uber's not a customer yet, but all of their competitors pretty much are. And why do they need real-time streams of data? Well, they're tracking where the taxis are all the time. People need to see a subset of those streams on their phone. And there's a lot of decisions that have to be made in real time. So all of these applications, here's this interesting part for us. None of our revenue is bundled up. The percentage of our revenue is not a majority coming from one place. So it really is this really nice horizontal distribution of the use cases for PubNub. But the other more challenging thing for us as we built up the company is not any one of our customers talks about what we do or what they need in the same terminology. So it really is a new space here, right? This idea of having a network, a global network like a CDN, but for streams of data going both directions, was something that people didn't have a name for. In fact, they didn't even really know they wanted it. They've seen World of Warcraft, right? They've seen instant messenger applications. They've seen Ubers. They've seen a lot of applications that take advantage of data streams. But there's no one term that people used ubiquitously. In fact, interestingly, people used to call this push notifications before mobile got big, and then that term kind of got usurped by the mobile companies. So for us, what we focused on really was what was the benefit to the customer, and that tended up being the same. Ubiquitous connectivity, low latency, high reliability and failover, global distribution, a lot of the same kinds of values. And why is that? It's because a lot of these, what I'll call real-time or always-on applications, they basically they're becoming more and more mission critical. So it was fine, in the old days when you could run a little socket server on the side and you'd open up a port and it would be fine. But now all of a sudden you've got these companies where if we go down, if our network goes down, their business stops working, right? There's no revenue coming in, their product stops working. So the infrastructure all of a sudden becomes a lot more about distribution, about global network, about how do you replicate data. So there's a huge number of DevOps challenges associated with that, some of the stuff we've learned and some of the things we still work on. The other reason we started PubNub was kind of our view that there were kind of so far 4 major trends in infrastructure on the internet. The one that I kind of first got into startups to jump on top of was this change from what I would call the static web to the dynamic web. And that was where I left Price Waterhouse as a big management consultant. Well, I wasn't that big. I was very junior. It just felt like I was big. But I was moving into the dynamic web, which was, hey, for the first time, it's so silly now, but back in the mid-'90s, people woke up and said, oh my God, this browser, this could actually be a platform for applications. It's not just static brochureware. And what everyone did, when I was at this company called Net Dynamics, I was like the 11th employee, no one had ever heard of us. And we spent the next 2 years evangelizing a few things. The idea that the browser could be a platform for applications, that you could use this language called Java on a server, what a crazy concept. And most people we're competing against were really building CGI scripts, leveraging last generation's technology. And the same thing happened again in the mobile web. So a lot of new infrastructure came up, not because it was cool, but because it was needed. Because the nature of mobile apps required different sets of infrastructure. And for the first 2 years, people were leveraging last generation's technology for this. And now this 4th trend has really been about the streaming web. Everyone's always connected, always on, right? We've got a massive amount of data always being created and consumed. It no longer makes sense to dump that into a database and pull it out later. So there's a whole new infrastructure needed that doesn't look anymore like a funnel where data is coming down into some servers and coming back up later, but a whole new application design and for that matter, operations for how we think about always-on applications, streams that are always happening, and the fact that this is just growing at a massive rate just because more and more people, more and more countries have more and more devices, whether they're IoT devices or mobile apps and so on. So we've stolen from Sun Microsystems the term the network is the computer. We figured they're not around anymore, so we're taking the term. And we started PubNub with this kind of tongue-in-cheek concept. What was the kind of network that powered the movie The Matrix? In fact, someone, the JFrog guy here, where's he still here, mentioned the singularity. And singularity is one of our core themes. In fact, if you go to our website, we say the network is the computer. Sorry, that's not what we say. We say one step closer to the singularity. So what we're talking about there is, literally what is the kind of things that networks have to do? Our thinking around this is that networks today are pretty broken. There really hasn't been any innovation in networks since I was in college. We still have IPv4 and firewalls and DNS and nothing's really changed there. But we really wanted to start with providing something directly of value to customers. So the first thing was real-time communication. So opening up sockets, keeping connections open, and providing a two-way publish-subscribe interface. And then this was kind of our pitch to our first VCs, by the way. Phase 2 is going to be scale and learn. So we're going to scale this thing up. We're going to get lots of messages on our network, lots of devices, figure out what other services people need. And then this is way before people talked a lot about microservices or containers. This is even before your article, by the way. No, we said, hey, we want to do computation in the network. We want to be able to do, just kidding, by the way. We want to be able to do we want to be able to do manipulations of the data as it routes through the network, which really people weren't thinking about. And I'll show you kind of how that's progressed. So some of the design parameters when we started off was we wanted to leverage this publish-subscribe paradigm. It's simple, it works, and people understood it already. So simply publish data into the network, and anyone subscribing gets it in a quarter of a second. And we've done that to millions of devices simultaneously. We've done that for one-to-one connectivity, like turning on a light bulb, but just ubiquitously being able to do that. Second design parameter was we want this to be a developer-centric network. In other words, we want to have APIs developers can use. We don't want to do top-down enterprise sales. We really want to make it easy for developers to adopt, to use the network without a lot of hand-holding. The third was we want this to work on every kind of device. So we built, as of last count, 76 SDKs. We have a big team that just makes it really easy to keep socket connections open on any kind of device. So you're really not thinking about network connectivity, firewalls, load balancers. You simply issue something like a pubnub.subscribe call, and that establishes a socket connection, keeps it open, catches up in case connections drop, just to make this whole connectivity completely easy and sort of abstracted from the complexities of normal networks, IPv4, v6, and so on. The next was latency. So how do we build something that gives you quarter-second global latency? So if I publish a piece of data, a message, it can get anywhere in a quarter of a second, and spent a lot of time architecting that. The fifth kind of big design parameter for us was making it a network. And part of the reason for that was the latency, but other part of it was also, hey, if people are building real-time applications, then they need to be they need to be redundant, and they need to be replicated. And so if you publish data into California, but that data center sinks into the ocean, I would sure like to be able to just kind of connect somewhere else and keep going. And so we designed this, really looked at companies like Akamai as a design sort of concepts, but really with a totally different architecture because they need to be two-way and multi-way streams. And then finally, security. Again, if streams of data stream applications we thought 6 years ago were going to become mission critical, there needed to be a new security model around this. So we launched that, and we got a lot of adoption. We actually launched this as a two-person company, actually. Most people didn't know we were only a two-person company. We started to grow and get a lot of customers, decided to raise funding, and we started to realize that what people needed. So over the last 6 years, we've been building out a set of core services, which just from the demands of our customers and our own expectations of the space, have been sort of playing into what a data stream application needs. What are the kinds of things people need? So the first thing we added was this concept of presence, which basically said, hey, if you're publishing data streams and you've got an open socket connection to listen to them, and people would say to PubNub, well, you probably know when those devices have disconnected off the network. So we want to know about it. So we launched a presence service, which is just like that green light on Skype, which tells you when a device is online or offline. We then launched various ways of multiplexing data. So you may want to publish millions of different data points in and be able in various ways to have the subscribers listening get different sets of the data. We realized that streams are great when when you're listening, but they're transient. And there's many use cases, from social applications to embedded devices to financial applications, where you clearly want to go back and look at those streams in the past. So we've provided different kinds of abilities to go back and play back those streams like a DVR. We added a number of different access control layers, of course, various gateways, because we want to be the Switzerland of data stream networks. We want to be able to talk any protocol. We want to be able to publish out to anywhere. We really the vision here is to be able to connect to and from everything. And then we realized that it's funny, if you've ever heard pitches from most companies, especially IoT companies these days, phase 1, build product. Phase 2, bring it to market. Phase 3, monetize the data. Right? This is like every pitch you ever see. It's always the last step is when the hockey stick happens on our financial plan, because we're going to monetize our data. And then we looked at it and said, well, these days it's important the data be real time. People want to pay for streams now. They don't want to pay for a database dump. Right? That's a new kind of a new thinking. Monetized data used to be selling you a database once a month. Now it really means getting a stream. And yet none of the customers we were looking at had any way to stream out data to their business partners. So we added a stream syndication layer so that, as we're kind of hopefully lining up our timing with the timing of people monetizing their data, they can simply publish into our network, provide an access token, and give people the ability to consume streams over time. So we've been doing this, and of course the last piece is providing, well, most importantly, computation, analytics and computation on the data going through the network. So I want to talk about that next. I want to talk about that. That's where microservices comes in and some other things. But before I do that, a few questions about why did we design as a network? There's some tactical reasons here, but there's also some kind of bigger reasons. So I talked about the obvious ones: redundancy, reliability, getting the same latencies if you're in Singapore or if you're in Frankfurt. Interestingly, complying with regional security. If you have a network, you can segregate and segment the network based on the kinds of data and the kinds of applications. We can now dynamically distribute load. What's interesting for us is we're seeing these emergence of these massive scale stream applications like a Periscope or Pocket Gems, where you've got just huge traffic coming in, and we can now sort of look at latencies and move load around. Whereas if we were just sort of some servers in a cloud, we wouldn't be able to do that. The other thing is another demand that you really, frankly, didn't see 6-7 years ago. And this is this idea of publishing one message and getting it out to everyone in a quarter of a second. Our first sort of demand for this came from Eurocup. Back in 2011 or 12, they were going to launch an app. It became the top app in 60 app stores, 60 countries' app stores. And the idea was they wanted one message that was going to get published. It was about a K in size, pretty tiny. But they wanted quarter-second latencies globally for everyone to get the soccer scores, field position, penalties, things like that in the soccer match, the football match. Because we've designed as a network, it's sort of a cascade design. A message comes in, it replicates, it routes through sets of tiers, and out distribute the load across many data centers. Because interestingly, most data centers can happily consume 1K, but don't like to burst out 1 million K in a quarter of a second. So, being able to distribute this out became a need that, frankly, an application that didn't exist, or a need for an application that didn't exist just a few years before. And then stateless router design, which is down there and I won't talk about. More importantly, we designed as a network because I think there's a new trend happening. We haven't talked too much about networks today. But as I mentioned, I don't think networks have really changed. The only innovation we've seen in networks over the last 20 years has been this big surge about 7, 8 years ago with SDN, software-defined networking. And that sort of went south, and it's doing interesting stuff. But there's a huge disconnect today between application-level developers and network-level developers. In fact, I interviewed at Microsoft for an internship job. I think it was in 91 or 92. And I knew a lot about software. I was a kick-ass developer. I was in college. I was one of those great developer types. And they flew me out to, I think it was actually their Houston office, and asked me a bunch of questions about, net masks and DNS and things that I understand now. I really knew nothing about in college. They didn't even teach that stuff. The network was this thing that you just took advantage of. And that really hasn't changed. And if the network is dumb, meaning it's just something that you send packets across, there are things like DPI, which I won't go into, but frankly, they can't do anything smart. The network can't actually be aware of your application and be able to manipulate the data as it goes through. And we really wanted to rethink this from the ground up. There's some like academic papers talking about resource-based networks, and that's sort of what we're thinking about, which is you just ask for a resource. We'll call it a channel. I want to hear about score updates. And I don't care where those servers are. I don't care what kind of firewalls I'm going through. I don't care about anything. I just want to hear this stuff. I ask for that resource in the network, and data comes to me as it gets created. And I think that's the way we need to be thinking about it, because if the network is also aware of the resources, the network can do a lot of interesting stuff, right? The network can filter, can route, can augment. You can actually put some logic, some application-level business logic in the network, right? And how do we do that? Well, 10 years ago, we didn't know. Now, it's pretty obvious. We may want to use microservices in the network because we want to be able to put application layer logic in the network at the edge. So, deep into phase 2, where are we? I think we've basically made good on the PubSub network. We've learned a lot about the services. We've got over 300 million devices on our network. We did 1.8 trillion transactions last month through the network. We've got some really nice scale. And we've got revenue from 75 countries today. It's been growing really nicely. We're closing many deals per month now, in many scores of deals per month. And I won't talk about security because I don't have time, but there's some interesting things you get from designing a smart network around security, which we can talk about elsewhere. But here's where I think we see things breaking down and why having a smart network is useful. Most of the talk about microservices so far, both here but I think also more broadly, has been about taking existing applications and moving them to a microservices container-based model. And that's great. I mean, clearly that's where most of the money and most of the applications are. They're existing apps. I think I heard recently that JP Morgan is moving like 100% of their apps into microservices, and it's a crazy investment that's going on. But also, interestingly, the question is for these new kinds of data streaming apps, what's breaking down? And what we see is that when you have applications that are using PubNub or a data stream model, often the publishers of the data have to do some kind of manipulation of the data before they publish it back out. And so even though this idea of a publisher being one iPhone and a subscriber being a browser or another iPhone makes sense, the reality is people are still using a funnel-based model to consume those streams, do some simple business process, and pushing it back out. And so that tends to scale. We see so many of our customers use that pattern, and so many of our customers having this big hard time still scaling up a number of nodes and servers down at the bottom. So our answer to that is combining the three things I talked about: a smart network, data streams, so messaging, and microservices. And we're launching it as PubNub blocks. And this is interesting, again, to bridge that gap between infrastructure and network people and application layer people. We're going to market in an interesting way. So yes, how does it work? Leveraging microservices and abstracting a lot of the complexity of that from our customers, you can embed little bits of logic into the network. So as data gets published to a channel, as it routes through the network under very low latency conditions, it can process simple business logic. What does that business logic do? Very broadly, augment data, route data differently, filter data, aggregate data, transform data. It can make outbound calls to enrich data, lots of interesting things. Very simple though, simple layer application logic. And so I think, rather than this model today where people are sending and receiving lots of data, sure, PubNub today works great as a way to get that to the destination quickly, but your servers are still there trying hard to keep up. We're seeing a model that we've been talking about here in a lot of different ways. The way we see the world, I don't know whether you call this serverless computing, back to what a lot of people like Chad were saying earlier. I don't really see it as serverless either, because I still think that not only are there servers in place, but you still have servers in place as the users of this, but you're using your servers in totally different ways. Here's the way I see it. Whether it's PubNub or another smart network, data is publishing and subscribing there. You're offloading a lot of your business logic into the network at the edge. And your servers are still here, but they're no longer the bottleneck. I see them more like a traffic police person, right? A traffic cop who's looking at what's happening and can change the rules in real time, can push new business logic, can grant and revoke access to devices, and so on. So it really changes the paradigm by which we develop, where your servers have this really important role, but not in this massively scalable way, but as sort of the controller for a big, wide, global, high-speed network. And I think that's the model that we are trying to evangelize, but we're not trying to evangelize it in a very infrastructure-y way. I mean, I think people who use our products here will use them and they'll build their own blocks, but which really aren't our sexy name for microservices, but we're going to market with an increasing catalog of functionality, okay? Of little configurable bits of functionality as starting points for developers. Again, I keep referring to you, Chad, sorry, but you said a lot of things, so I had to change my presentation. But Chad actually mentioned earlier, which I really liked, this concept of maybe the algorithm economy, right? I would also add to that maybe with the microservices world, we'll see this concept of like a building blocks economy as well, where you're starting with these building blocks. I think we went down the wrong path in the mid-2000s with the concept of widgets, where you would plug widgets into your website and they would all do different things, but they became these black box, pieces of functionality that didn't work anywhere. But if you can provide, both the algorithms, but also little bits of business logic that you can provide to customers, then we're creating an ever-growing catalog of these microservices, that really of these blocks, as a starting point for the application level developer. So that's it. I'm done. I had by the way, this last slide was this really awesome, sexy video with like transitions, and it ended with this beautiful PubNub logo with spinny global stuff. Stuff is really neat. But then it turns out QuickTime's not installed on it. So I'm just going to have to hand pop up. You see it in your minds, exactly. All right. So any questions? I think we got 4.5 minutes. Yes. Yeah, so actually Indonesia, we've got a lot of customers from Indonesia. I think one of them, isn't it Gojek from Indonesia? Remember? Yeah, Gojek's using PubNub for all that stuff. So, when I talk about PubNub, I say we don't solve one big problem. We're sort of the death by 1,000 paper cuts problems. That's one of, or few of many of those problems. For example, that's an extreme example of where the publisher is publishing at a faster rate than the subscriber connection, or the ability for the subscriber to stay connected. So we do a lot of little things. We're timestamping every message to the nearest 10 nanoseconds. We are catching up when the reconnects happen. And then if we detect that there's been multiple messages that have been queued up waiting for you while you're getting reconnected or while you're too slow to consume, we start to bundle in gzip at different windowing times. So you're getting smaller amounts of bandwidth, with more data in a compressed format. So a lot of little things. Good question. What's the transport mechanism? I actually didn't have time to make the point that the OSI 7 layers in networking is kind of breaking down. Right, so this level, you see protocols where we're level 3 and level 9. There isn't even a level 9. So I think for us, we muddle around and tinker with a lot of stuff. But basically, what we find that works ubiquitously because HTTP always gets routed. HTTPS always gets routed sort of through. So what we do is we have a protocol that tunnels through HTTP. So it's sort of almost like a VPN tunnel that goes through an HTTP connection. Yeah, and I can get into the details, but we actually, yeah. Any other questions? All right. Okay, I did it without falling asleep. Thank you, guys. All right, I really appreciate it. Thanks so much.